So now we're going to talk about some collision detection. Obviously a very important element to pretty much any video game you're going to create. Almost any game is going to require some form of collision detection. And there's a lot of different types of collision detection. There's box to box, which means do two rectangles touch. There's circle to circle. There's point to box, which is good for checking to see whether a mouse clicks inside of a button. Obviously there's things like circle to box and whatnot, and they can get much more complicated, and even right up to like pixel perfect collision detection, and sometimes you get a combination thereof. Like for example, you might want to have a player who's inside of a box, which is their basic destination rectangle, but you may want to know specifically, let's say for example you had a fireball coming around which has its own box. Okay, flames coming out here and everything like that. Now you may want to know specifically what part of the body that flame hits with. So first thing you're going to do is you're going to check to see whether these two boxes collide. Once you know that's true, that's the cheapest form of check that you're going to do at this point. Then what you could do is you could break up this box into smaller boxes. Maybe you have a head box, maybe you have an arm box, maybe you have another arm box, maybe you have a torso box, maybe you have a couple leg boxes. So what you could do is, once you found that there's a collision with the big box, then you could do a further collision check with all the little boxes to see which body part it actually collided with. And this gives you a lot more precision with a cost. Now of course you simplify that cost by saying I'm only going to check those small boxes if I find a collision with the big box. So most times you're only ever going to be colliding with one thing, not all 1, 2, 3, 4, 5, 6 things. So that's a combination of the two. So what we're going to talk about right now is the idea of box-to-box collision detection. And just to demonstrate this, let me just get rid of all this stuff here. What we're going to talk about is if you had a subprogram that says, do two boxes collide, true or false? Let's say we have a box here, and let's call this box 1. Now, the way to test for collision detection with two boxes, you're actually not going to be checking for a collision, because the problem is there's so many possibilities of collision that most people don't think about. You're going to miss all these possibilities here, and I'm just showing you the surface checks here. There's other things where it's right inside, or maybe it contains the whole thing. There's all these different options, and there's many more, of course, and because there's no guarantee of what size your boxes are or anything like that. So I'm just going to back that up. And so instead of checking for a collision, what we're going to do is we're going to check for impossible collisions. And if we check for all impossible collisions and we find that none of the impossible collisions are true, well, that implies that it must be a collision. So let's think about what I mean by that. So if this is the left wall of box, this is the right wall of the box, this is the top wall, and this is the bottom wall. Basically what I'm saying is, if I have a second box, let's say over here, box 2, if the right wall of box 2 is less than the left wall of box 1, it is physically impossible for there to be a collision there, because it's too far to the left. So that's one check. We know that that's an impossible collision. So if box 2 dot right is less than box 1 dot left. Now this is just kind of like pseudocode, mind you. It's not real code, just to give you the idea and generally speaking. So that's one of the possibilities. Another possibility is we go to the opposite side. So we have box 2 again. So this is saying if box 2 dot left is greater than box 1 dot right. Now again, this is an OR statement, because if any one of these are true, then that means that it is an impossible collision. They don't all have to be. Any one of them is true. That means it's physically impossible. So that takes care of left and right. Similarly speaking, we can do the top and we can do the bottom. So we have box 2 dot bottom is less than box 1 dot top, or box 2 dot top is greater than box 1 dot bottom. Oops. If any one of those are true, that means it is physically an impossible collision, so we need to return false. It is definitely not a collision. Now, of course, if all of those failed, that means our else case means that there absolutely is a collision. So we return true. Now, we don't know what part or where it collided, but we do know that it did collide. So that's our entire check. So let's go over to our code and let's try this out. Let's go write it out in long form. So in Eclipse, what I've done is I've created a simple subprogram called box collision, which has two rectangles, box 1 and box 2, exactly what we were talking about before. And we're going to write out the same code that we just saw a second ago. Now what we need to realize though is that there is no such thing as box 1 dot left and box 1 dot right and so on and so forth. So we have to know what these actually mean. So let's think about this for a second. Left is the same thing as x. Right is the same thing as x plus width. Top is the same thing as y, and bottom is the same thing as y plus height. So we're going to keep these in mind as we write out our logic in our actual program. So going back over here, we want to check to see if box 2 dot, now the right side, which is the same thing as box 2 dot x plus box 2 dot width, if that is less than box 1 dot x, then we know that's an impossible collision to the left hand side of box 1. Now going down, let's write another one. Let's go to the next one. The next one is very similar. So now we want the left side of box 2 dot x, is that greater than box 1 dot x plus box 1 dot width? So now we've checked out the left and the right side options. So now we got to do the exact same thing with top and bottom. What did I spell wrong? Why is that? Oh, just because I haven't finished the statement yet. Now the top and the bottom are going to be almost identical. We just have to change our x's and y's and our widths and heights. So we're going to say box 2 dot y, oops, plus box 2 dot height. If that is greater than, sorry, less than box 1 dot y, which is box 1 dot top. So is the bottom less than the top? Yes, that's what we care about. Oops. And then finally our last statement, box 2 dot y, is that greater than, so is the top of the box greater than the bottom of box 2, or box 1? Box 1 dot y plus box 1 dot height. If all of those, or if any one of those results in a true, then this whole statement needs to return a false. Otherwise, return true. So there is our complete logic. I'm not sure why we're getting an error here. Why are we getting here? Oh, that should not be a void. That should be a boolean. That's why. So there we go. We have our entire logic. Now this will check any two rectangles to see whether any two rectangles collide. Now in the next video we're going to start, or in future videos we're going to start and demonstrate this. I don't want this video to go too long, but what you're going to find is that this will always get a perfect collision check with our boxes.